Good morning, and thanks to everybody for taking the time out of your day to view this webinar. I hope you got a lot out of it. We've had some very, very, very good feedback out of it or from it. One thing I would ask, we're going to do a Q&A session here. It'll be as short or as long as we have questions. So if you do have any questions, please don't hesitate to type them in and email them to me so that I have them as we go through this. First of all, my name is Jason Spangler. I am the division manager for flooring, responsible for the Rapid RH concrete moisture testing, also responsible for the smaller line of hand meters that we do for testing the moisture in wood, finished wood products and wood subfloors. My direct number is 800-634-9961. And my direct extension is 235. I always give that out just because it seems like it never fails that either with the delay in how this webinar works or with people remembering things as time goes on, I want to make sure that you have my direct information so that you can call me if you have any questions, because at the end of the day, that's what we're here for. We're here to make sure that you have any questions, concerns, or issues that you might have taken care of and resolved so that you can go forward and actually make and do what you guys do, which is install floors or inspect projects or complete projects. So with that being said, we'll move on to our first question that I get quite often, which revolves around how do I know how thick the concrete slab is? If we're talking a slab on grade or a slab below grade, most of the time I tell people on new construction projects, again, you have access to construction documents, you have access to field superintendents who are actually on the job, but again, there are still some inconsistencies even based on what specifications are. If you have a situation where you're doing renovation work, the nice thing I always tell people is, especially if they're moving any kind of plumbing when it comes to bathrooms and things along those lines, would be the situation where you're able to actually see an open trench and be able to gauge based off of that. Worst case scenario, and what people are doing out there in the field, is they will actually take a smaller diameter hole and drill it through the entire depth of the concrete. Well, the first thing I have people say is, well, what about the vapor retarder that's below it? And again, it's not perfect world, but like I tell people, if that's the worst thing that happens to that vapor retarder is you putting, say, a 5/8 inch or even less, a 3/16 inch hole, something small in that vapor retarder, if that's the worst thing that happens, done pretty well. But usually what will happen is they'll drill a smaller diameter hole through the concrete, take some pliable wire, make a J-hook on it. Usually the J-hook is going to be a little bit bigger than whatever the diameter of the hole is, so that it compresses it when you're pushing it down. As you push it down through the hole, it'll get to the bottom. You'll feel that wire spring out a little bit. Pull it until you feel resistance on it. Take a Sharpie, mark it off the top, pull it all the way out. You can see kind of where the curve was in the J-hook. See where the Sharpie is. Gives you a really good idea. I tell people don't turn the slab into Swiss cheese, obviously, but if you take a couple of random samples opposite ends of the building, should give you a good representation of what you have going on. If you're looking at elevated slabs, I will always tell people it never fails, especially if they're running any kind of venting or plumbing stacks through from floor to floor. They cut the pan decking out quite a bit bigger than what the pipe is. So if you were to go into a stairwell, if you were to go into something like that, you're probably going to find access to be able to get a cross section of what the thickness of that floor is. So that leads me to the second question that I get a lot, which is, in pan decking, when you have highs and lows, how do I calculate the thickness, one, and then where do I drill? So first thing is, unfortunately, the ASTM standard is completely silent on what we're talking about. Now, that being said, the ASTM subcommittees are actually looking at this. This is one of many, but this one topic, looking at it very specifically to see if they can give more guidance on how to drill and where to drill in the pan deck. That being said, there's usually two ways that are being done currently in the field. One is people are looking at identifying where the thickest portion of the pan is, and then drilling 40% of that. So then again, next question is, how do I identify where the thickest portion is when you have highs and lows throughout? Usually you can get a very inexpensive metal detector that works much like a stud finder on a wall to find wood studs, but you can use it on the surface of the concrete. And that detection technology is typically strong enough that it'll pick up the high parts of the metal decking, but not go all the way through to the low parts. So you can take it and scan it from section to section, scan across, mark, scan across, mark, drill right in the middle. Again, much like detecting where a stud's at in a wall. That's one way. The other way is they're looking at coming up with some kind of, there are people out there who are using an effective thickness calculation, taking the cross section of the thinnest part and the thickest part, putting them together, coming up with a number, and then doing 40% of that and drilling anywhere on the floor. Again, our recommendation is to try to identify where the deepest section is until the ASTM committee can give us more guidance specifically on how to do things. Next question I have, can you reuse the same hole that was initially used in years past? How long do probes last? And can you use older probes? Can you reuse the same hole that was initially used in years past? Okay, so I'm going to try to break this down, and I'll try to, because there's like 2 or 3 questions here, really. I'll answer it the way I'm interpreting it, and if it's not correct, Daniel, please just give me a call directly, and we can talk about it specifically. Can you reuse the same hole that was initially used in the past? So what I'm guessing is that you've had a situation where you've tested with the Rapid RH, you've put a floor, you've deemed it to be acceptable, you've put a floor down, and now for some reason, potentially something's happened to the floor, so you want to go back in and actually test that same probe. Can you use it? Yeah, theoretically you could. I can't guarantee it because I don't know what's really transpired with that hole, with the concrete, with the floor itself. Most of the time when you buy, not most of the time, when you buy a package of sensors, you are going to get a NIST traceable certificate of calibration that comes with the Rapid RH 4.0. That NIST traceable is either going to have stamped on it, if it's some of the older stock, it's going to have a 2-year window that the sensors are good for. And it'll say like from August of 2012 to August of 2014. That's when the probes are good for, and you should be keeping that NIST traceable certificate with the job file where you used those probes. On the other side, in the more recent packaging that we've done, we've gone back to when the calibration on the certificate was actually, or when the calibration on the sensors was actually done. So from the date that's stamped 2 years forward is the accuracy date for those sensors. So if you were to put something in that had a certificate date of today, and you went back and tested it in 2 years or less than 2-year time period, then in theory, yes, that sensor, if it does read, that sensor is reading accurately. So hopefully that answers that. Again, a lot of stuff happens. Now, what we typically will tell people is, if you're going to use the system, the Rapid RH system, the way it's really intended, then you're not thinking about going back and being able to use it later. But what you're thinking about is being able to document a moisture test with a floor. And when I say that, once you've gotten to a point where you've read you figured out that you either need to moisture mitigate, use a better adhesive, or the concrete's dry enough. Then you're going to go through and do your final floor prep. In every pack of RapidRH 4.0 sensors, you're going to have that metal disc. And that metal disc is really intended twofold. One is you're going to put it down into the hole, into the sensor, and you're going to skim coat over the top of it, so that when you have your documentation for where you did the moisture tests, you know, part of it is the actual readings, but part of it is a grid sheet that gives you kind of an X marks the spot, 10 feet off this wall, 15 feet off this wall. Those two pieces together, along with the metal left and the skim coated patch over the top of that sensor, helps tie everything together. Question is how? Okay, so let's run through a scenario that I push out to the nth degree, but just to be able to prove a point. You install a floor, the floor fails, everybody's standing around. First question that everybody's going to ask is, did you do moisture testing? You're going to pull out your piece of paper. You're going to show them the results that you got. They're going to look at it. They're going to say, okay, the results look good. The numbers look good. Now the question is, how do I know that you didn't just make all this stuff up while you were sitting at your kitchen table this morning? And that's a great question. So nice thing is, the other part of that piece of paper that you have is a grid paper. So you have an X marks the spot. So now you can go out on the job site. You can take that grid paper, you can take your 8 paces off this wall, your 10 paces off this wall, get into a general vicinity, and with a very inexpensive metal detector, you can scan across the floor and very quickly pick up where that metal disc is that you left. And so now you're able to take that piece of paper with the results and the grid paper and tie it all in with this specific job and this specific floor. And at that point, the burden of proof is on somebody else to be able to prove that you did something inaccurately. To sit there and for me to say that you can go back and read those things to prove that they're the same as they were before, that really would be something where I wouldn't do. That's not really what the benefit to this whole thing is. Is that possible? Absolutely. Just depends on really what's happened. And again, it looks like how long do the probes last? Can you use older probes? Again, older probes are going to be defined, you know, you have a two-year window that they're good for. So as long as the NIST traceable certificate of calibration that you have either has a calibrated date on it that is less than 2 years from the date that you're looking at reading the probes, or if when the date that you're looking at reading the probes is within the 2-year date that's on the NIST traceable certificate of calibration, then you're fine. Okay, looks like those are all the questions that I have. Again, my name is Jason Spangler. Phone number is 800-634-9961. My direct extension is 235. So if anybody has any additional questions that they think about, or they have anything that comes up in the future, please don't hesitate to call us. I want to say thanks for taking the time. And also I want to thank everybody and wish everybody a happy Thanksgiving. Thanks and take care.